So this next section is going to be focused on taking a look at email and getting greater control of the security over the messages, the recipients, the contents that are associated with our emails. So everybody has a legitimate business or personal use for passing email back and forth. When we look at the number of malware infections that we're getting within corporations these days, the majority of them are coming, in most scenarios, through either web delivery or through email delivery. By adding additional layers of protection, this was something that could supplement your existing firewall solution, and it's going to give us greater granularity, greater control over specifically email traffic. So there were limitations, there were things that we could apply and protections within the ASA, also within SourceFire. But what we see here with the ESA is the ability to leverage a completely different set of dials and control knobs to basically regulate the flow of email through the environment. So email being a critical business tool is something that we've got to allow, we've got to permit it, we can't stop it from passing, but we've also got to be very vigilant in defending against malicious materials that may be coming through email. So the solution that we have before us is the Cisco ESA, or Email Security Appliance. It's essentially a type of firewall, but it's an application firewall that's really built for granular control of email traffic. And when we say email, there's MAPI, there's POP3, there's IMAP. What we're looking at specifically here is the sending of emails. A lot of these other mechanisms are going to be used for retrieving your email. What we're looking at is the email that's being transferred from one mail server to another, sometimes referred to as relay agents. When we talk about looking at the Cisco ESA, what it's going to be able to do, well, it can stop spam. If we take a look at the ASA and the Firepower solutions, yes, they can protect the mail server, and we could do some things with very simple rules to stop mail, spam emails, but it wasn't like we're getting a constant feed of the latest, greatest details, and it wasn't like we had dedicated engines that were just built for processing spam. The ESA has got a lot of components under the hood that are going to help it identify spam in a much more intelligent way. And I'd say a much more intelligent way than even other vendors can. My personal statement, not Cisco's, but I remember what life was like before Cisco made the Ironport acquisition and how it's changed after. So the ESA's goal, okay, of course it's a spam filter, but what is a little bit more exciting from our perspective as security engineers is the advanced malware piece. We've got the ability to tie into third-party antivirus engines, and as well as Cisco's AMP, and we can leverage it for really intelligent scanning of contents that are within email. Big concern for a lot of customers these days is phishing scams. So it can look at a ton of information that your users are not going to be looking at to identify a phishing scam. Typically, even you or I, when we look at a phishing scam, we look at the way the email is written, we may look at the sender's domain, we may look at the notes or the source of that particular email and make sure that nothing was happening funny with it on the way here. But ultimately, do we really know, looking at those IP addresses, that the server has changed or that it's coming from a different geolocation? A lot of times we just don't have that insight. So the ESA can leverage a lot of additional metrics that typical users aren't using to distinguish, is this email legitimate or not? Ultimately, this can also help us with data loss, which sounds a little bit weird, jumping from phishing to data loss, but realize that we've got the ability to scan your email when it's coming into the organization and then when it's also leaving the organization. When that email goes out, we can apply DLP, and DLP, or data loss prevention's going to give us, the administrators, the ability to basically make dirty word lists. So what you could put in there would be potentially, let's say that you're working for a company and you've got projects and the projects haven't gone public yet, you're using code names to refer to them. So they say, Project Whistler or whatever it's being called. You would do a filter for any documents, any emails that contain the word Project Whistler. It's like you're not supposed to talk about the secret project in those mechanisms. So the things that we can use to make sure that we're not leaking any data that we might be without knowing it. Sometimes it's something nefarious. Just in the last week or so, one of the professors from Harvard was caught, working with Chinese spies, and he was previously awarded being one of the top researchers in the world and working against viruses, working in the biological space. And unfortunately, a lot of our best research was being stolen by China, and this guy was getting paid to do it. So there's a lot of mechanisms you're going to have to use to find those types of actors. We've got them in all environments, unfortunately. DLP is going to catch maybe the careless use. And when we look at actual, people that are performing this at the nation state level, we're going to have to look quite a bit harder. We'd start looking into things like steganography. Again, there's additional tools that you could leverage there. What we're looking at here is maybe not nation state actors, but this would start to give us maybe some leads that would take us in that direction. So when we scan for malicious threats, we can look at attachments, we can look at embedded URLs, and then of course we can look within the email's body content itself. So the goal of the Cisco ESA, of course, is to secure your email. One of the nice things that assists it in doing so is that it's getting constant updates from Cisco's Talos team. So this is their global threat management security team that's writing and adjusting and kind of fine-tuning those rules on a regular basis. You're getting constant updates about who all the various threats are that are out there. So this is kind of neat. This is showing us what happens when email comes in. And effectively, we need to categorize the email. We can say that this is good, bad, or unknown. And if email comes in, and think about how much email your company is processing each day, it's probably a heavy amount. If we've got the ability to identify good traffic, we go, oh, we deal with this mail server every day. We know those users. They go back and forth 10 times a day. These are the same relays. These are kind of like the same hops that I always see. All of this looks normal. So when we see what we know to be good traffic, we go ahead and deliver it. And it's important to identify things that don't require thorough analysis early on, which is why we're also using reputation data from Cisco Talos that allows us to monitor email as it comes in, and we can identify stuff that's garbage before we use advanced analysis upon it. We can just look at things within the headers, we can look at the sending IP addresses, we can look at known patterns, and we can say, you know what, there's no chance that this is good, this is absolute trash. We'll throw it away right away before we use these advanced inspection engines. Those are really gonna be kind of dedicated for our unknown emails. So we go, okay, well, what about this stuff that's in the middle? We don't know if it's good or bad. Well, this is where we can start to look at the context of the email, who it's coming from, what it contains, when it was sent, the locations of servers, etc. And then by kind of considering this contextual data and leveraging additional intelligent inspection engines, we can make good informed decisions on whether email should be delivered or not. So as traffic comes in, we showed tens of thousands of connections. The Cisco ESA is built on something called Async OS. This is kind of their customized architecture based on the BSD kernel. And they built this to really just be able to be a purpose-built. I feel redundant saying that. They built it to be purpose-built, but they began with the end in mind. They said this is going to be a dedicated operating system, not for desktop publishing, not for internet browsing, not for a multi-user workstation with secure user accounts, and we're not focusing on those things. We want to make a dedicated appliance that's just a machine that can handle tons and tons of email. And part of the way that it can do so is that the OS is very integrated into the way that the services handle incoming email. For example, just the process of handling all the connections of all the attempted deliveries is something that has to be thought of. The mechanics and the defenses that we can use for handling denial of service attacks or handling just floods of emails, we've got to have a really good engine just on the front of the house to be able to handle with the intake process of this emails. So yes, we need to think about the surge of connections that we could establish and staying stable and being able to be a workhorse and carry it. But as soon as all that stuff comes in, we need to filter it and make sense of it at an extremely high rate. We need to say what's good, what's bad, what's unknown. Now, of course, the unknown stuff that requires that further analysis, that's where it's really going to cost you in terms of resources. How much box did you need to buy? How big of a unit? Well, it depends on how much spam am I actually sorting through. The stuff we can throw away early on isn't that impactful. It's the stuff that we've got to dig through with these series of filters. So we see our work queue. This is where we leverage message filters, anti-spam, antivirus, Cisco's AMP, Graymail. This is like the opt-in email, right? So maybe it's a company that you like. I like BMW, I like Porsche, I think they make fantastic cars, but I don't necessarily need advertising email from them every day. However, from a spam perspective, I did check a box when I was filling out a profile on their site or getting a vehicle worked on that said, you can contact me. So they're legally in the right. I told them to contact me. I just didn't think it would be coming in, once or twice a day. So when we see those types of emails, this is what we consider as gray mail, because it's a gray area. It's not really spam, but it is marketing materials. You opted in, but it keeps coming. Again, we can create rules for this. You think about yourself, you go, oh, I might get maybe 10 of those a day. Go, well, we've got 75,000 users. That's a lot of time that's being wasted by a lot of people for things they may not be interested in. So whatever is appropriate, you could create a custom rule for. The same thing is true of email content. And then when we take a look at outbreak filters, this is where we could potentially control attacks that are flooding through email. So we've got a series of checks that we can apply to this content. And then it's almost like you could divide this as stage 1 is intake, stage 2 is the actual processing, and then stage 3, where you're sending it out again, that's got a whole separate collection of services and rules that you can configure for how the mail is going to be relayed out of your ESA. So technology use case, imagine that we want to have inbound email filtering, and of course that prevents spam, it prevents malicious email attachments from coming in. And then we take a look at outbound email filtering. This is useful for a couple things. We said one, DLP. We want to make sure secret stuff isn't leaking. And again, that happens unintentionally. Somebody goes browsing for a document. They've got 50 projects. They clicked on the wrong folder with the similar name and grabbed a wrong document and sent it out to a customer. That stuff happens. It wasn't ill-intentioned, but it doesn't make it any less catastrophic. So this is just an extra round of checks that we can apply to look at what's leaving the organization. Beyond DLP, what about things that could be potentially malicious or hostile? Right? If I work for a company and you're a client of that company and we're just communicating back and forth, I send over an attachment to you, you launch the attachment, and unfortunately I didn't realize it yet, but I was infected by a logic bomb, which is going to push out ransomware. Now you're, let's say, an administrator at a hospital. You see how fast that gets scary. And when we start looking for patient zero or root cause, the fact that the hospital's vendor was responsible for sending them the document, which included the ransomware, wasn't even a phishing attack. You can't train people against that. It's one thing if you're phished. It's another thing when you're working with a partner and they just grabbed the wrong document or made a mistake or they were a victim and didn't realize it. Again, by leveraging outbound scanning, it's a check to make sure we're not attacking anybody else. Again, we wouldn't attack anybody. A lot of times it's unintentional. Just keeps us out of an embarrassing situation. So under the hood, we said that there's a lot of inspection that takes place. We'll go into some more detail about it. But for now, just realize that there's an anti-spam engine that'll make sure that the content that we're receiving isn't unsolicited advertising. And then if it is, we toss it. Don't do further inspection. But if it is known to be good, because I think a lot of emails spam, so it's like throw as much away as we can. Okay, if we know that it's good, now let's do some more intense scanning. We'd push it over to the antivirus engine where we could leverage Sophos or McAfee. Those are going to require separate licenses, by the way. And again, this is kind of nice because it just shows you kind of like an order of operations, what happens with email from the perspective of the ESA. I'm going to go ahead and stop here just to break it up, but we'll continue in a second video.